Welcome to the Spirit of Apollo. I'm your host, Mark Lesmeister. Today we're going to complete the model by building the support stand that comes in bag 12. While I'm doing that, why don't you watch this about the final Apollo missions. The Apollo program did not end with Apollo 13. The remaining 4 lunar missions, as well as the missions that grew out of the Apollo Applications program, made many important scientific and technological contributions. Apollo 13 was slated to be the first fully scientific mission after the more technologically oriented Apollos 11 and 12. However, when Apollo 13 was unable to land on the moon, that role fell to Apollo 14. But Apollo 14 is probably best known for the 2 golf balls that Alan Shepard hit. Alan Shepard was the only Mercury astronaut to ever walk on the moon. Apollo 15 was the first of the so-called J missions. These were extended missions that featured a lunar module that could remain on the moon for up to 75 hours, and which also carried the Lunar Roving Vehicle, or LRV. On this mission, Commander David Scott performed the famous Galileo experiment, in which he dropped a feather and a hammer, the feather being a falcon feather in honor of the all Air Force crew. The landing site for Apollo 16 was chosen to be in the lunar highlands. This was to allow the astronauts to gather older material than previous flights had gathered, because previous flights had landed either in or near the lunar seas, or maria as they're called. Apollo 17 was the last human mission to the moon so far. It was the first mission to feature a scientist astronaut. Jack Schmitt had a PhD in geology from Harvard. Skylab was the first U.S. space station. We've already discussed how it was constructed from an unused S-4B stage of a Saturn rocket. Operations on board Skylab included a solar observatory and hundreds of scientific experiments. Skylab contributed greatly to our understanding of the challenges to be faced in long-duration spaceflight. The Apollo-Soyuz test project was really the first multinational spaceflight in which spacecraft from 2 different nations docked in outer space. In this case, it was a command and service module from the United States and a Soyuz spacecraft from the Soviet Union. This mission laid the groundwork for the Mir shuttle program, which was to come later, and the International Space Station. So this is the completed LEGO Saturn V rocket model. It is displayed horizontally, much as the remaining real Saturn V rockets are, and it is shown with the lunar landing static display and the splashdown static display. There are 3 Saturn V's on display today. One is at the Marshall Space Flight Center in Huntsville, Alabama. Another is at the Kennedy Space Center in Florida. And the third is at the Johnson Space Center in Houston, Texas. The one in Houston is the only one that is made completely of parts of Saturn V's that were intended to be launched into space. There are parts of Saturn V rockets on vertical display at various places, and there is a replica vertical display at the Marshall Space Flight Center. These displays constitute the physical legacy of Apollo. Let's look at some other aspects of that legacy. Of course, one of the most important legacies of Apollo are its scientific discoveries. Before Apollo, it was speculated that the moon was a primordial lump, unchanged from when it was formed. We now know that it has evolved in ways similar to the terrestrial planets, forming a complex structure. Like an onion or an ogre, we know that it has layers. Another scientific discovery concerns the moon's surface. The surface of the moon is old. As such, it preserves a record of meteorite impacts from very early in the history of the solar system. And just as you can learn something about a person by studying how time has changed their face, by dating the various craters on the moon using the samples returned by Apollo, scientists were able to calibrate the geologic timelines of the other terrestrial planets that have observable craters. The moon and the Earth look very different on the surface, but just like cousins who might seem quite distinct on the surface, but share some similarities when you look closer, we now know that the chemical compositions of the Earth and the moon are very similar. This suggests some common ancestry. Beyond the scientific discoveries of Apollo, the legacy of Apollo is to be found in the technological breakthroughs in space flight that it fostered, some of which are still in use today. The Orion capsule and the Space Launch System rockets that will carry astronauts to the moon and beyond incorporate concepts and designs such as a steerable capsule and splashdown recovery that were invented in the early days of spaceflight. Another legacy of Apollo are the spin-offs, products that we use every day that developed from Apollo. Everybody knows about Tang and Velcro. Of course, these products were not invented for the space program, but innumerable other things were developed using Apollo technology. These include memory foam cushions, reflective mylar materials used in space blankets and insulation, credit card and ATM software, computer joysticks, cushion insoles, and ear thermometers, just to name a few. I watched the 50th anniversary celebration of the Apollo 11 landing from the hospital room of a family member. I remember thinking how much of what surrounded us at that moment was invented by or influenced by Project Apollo. In the building, there were CAT scan and MRI machines that used Apollo digital imaging techniques. The computer I was watching used microchip technology. NASA didn't invent the microchip, but they were by far the largest consumer of computer chips in the early days. During Project Apollo, some 60%, that's 60%, of the chips were purchased by NASA. By providing a market for high-quality chips and pushing to reduce the size of technology, Apollo helped usher in the microcomputer revolution of the 70s and 80s. And I was taking pictures of the event with a cell phone camera based on CMOS technology invented by NASA engineers. The 50th anniversary celebrations highlighted the most important legacy of Apollo, and that is, it changed our view of what was possible. Nowadays, when NASA or even private companies like Elon Musk's SpaceX develop plans to return to the moon or a mission to Mars, no one doubts that we could do it if we put our minds to it. It has become a figure of speech. If we can put someone on the moon, why can't we? In the movie Apollo 13, Jim Lovell, played by Tom Hanks, celebrates the Apollo 11 landing with his wife Marilyn. He says, "From now on, we live in a world where man has walked on the moon. It's not a miracle. We just decided to go." In 2016, I had the opportunity to attend the premiere of The Last Man on the Moon, a documentary about Apollo 17 astronaut Gene Cernan. Before the movie, Captain Cernan made some brief remarks, including the line from the movie, "I walked on the moon. What can't you do?" Thank you for joining me on our exploration of the spirit of Apollo. Wherever your journeys may take you in the future, Godspeed.